Question 12. A gas mixture contains 82% percentage by mass of methane and 18% percentage by mass of ethane. If a 15.50 gram sample of the gas mixture is placed in a 50-liter container at 20 degrees Celsius, calculate first the total moles of gases. Okay, but first, to find the moles, you have to find the mass of each gases first. So here's how we're gonna do it. So write out your storyline first. Okay, so you've got 82% of methane, okay, and 18% of ethane. Okay, so they are placed in they are later on mixed in one container to form a total mass of 15.50 gram, volume of 50 liter at temperature of 20 degrees Celsius. Okay, so we need to find the mass first. We've got the percentage by mass. So write down your percentage by mass formula that you've learned back in chapter 1. So which is the mass of solute? Well, in this case, our individual gas divided by the mass of solution, which is our mixture, times with 100%. So we want to find the mass of solute first. Okay, so make sure that so rearrange your equation to make the mass of gases to be your heading. So mass of gas is equals to the percentage by weight times with the mass of solution divided by 100%. Okay, so cancel off this percent. So now you can find your mass of CH4, which is 82 times 15.50 divided by 100. The mass of CH4 would be 12.71 gram. For the mass of C2H6, that would be 18 times 15.50 gram divided by 100, 2.79 gram. So now put your respective mass into your beaker. So this would be 12.71 gram and ethane would be 2.79 gram. Sorry, 2.79, yep, that's right. Okay, so the next question is to find the total pressure in atm. Okay, so for question 2, we've got 3 equations that we can use to find the total pressure, but we're gonna choose the best based on the information given. So the first one is to sum or is to add up the pressure of CH4 plus the partial pressure of C2H6. Or the second step is to using the mole fraction. Okay, which is you rearrange this based on the Dalton's second equation, or you can use this equation of PV equal to nRT. But remember that your volume must be total. Alright, since the question asks for the total pressure, right? So if you want to use the PV equal to nRT, then all the pressure, mole, and temperature must be the value of the total as well. Okay, and R is gas constant, which has a unit of 0.08206. So let's check what information that we have that would be easier for us to find the total pressure. Do we have the information about pressure? Nope, we don't have the information about pressure of CH4 or neither the ethane. So this would be difficult for us. And this would be, and the second question is not suitable for us to be used as well, because we don't have the pressure of CH4. So we're gonna use the last equation, which is the ideal gas equation, to find our total pressure. So rearrange your ideal gas equation to become PT equal to N total and RT divided by volume total. Okay, so the mass, you can find it. Okay, you've got the mass for each gases already. R is given, T is given, and volume is given as well, right? So find the total mole first. So first find the mole total first. So the mole for CH4 would be 12.71 divided by 12 plus 4, which would be 0.7940 mole. Okay, remember class, mole find answer must be in 4 decimal place. Meanwhile, the mole for C2H6 would be 2.79 divided by 12 times 2 plus 6, 0.0930 mole. Okay, so your total mole would be just the sum of these two mole, which were gonna be 0.8870 mole. Okay, so just substitute your mole total into your ideal gas equation. Okay, so second step, calculate your total pressure. So where is it? Okay, so your mole is 0.887 times 0.08206 times, okay, don't forget to convert this temperature into Kelvin. Go. So 20 plus 273 divided by 15. So the answer will be 1.42180 m. Alright, so the third question is to find the partial pressure of each gas. So that's why we couldn't use the first and second equation to find out total pressure, because we gonna find it at the last step, at the last equation. Okay, so we're gonna use the Dalton's law formula of partial pressure, because which is the second one, because you've got the mole already. Alright, so your partial pressure of CH4 would be the mole of CH4 divided by the mole total, okay, which is the mole of CH4 plus the mole of C2H6, okay, times your total pressure. Okay, so this would be 0.794 divided by 0.887, 0.093 divided by 0.887 times with 1.421. So that would be 0.149 atm. Okay, so that's all for the question 12. Okay, I just want to highlight that note. You have to make a note. All gases involved in Dalton's law are ideal gas. Okay, so that's why we can use the ideal gas equation to answer the second Roman question. Okay, so you can use PV equal to nRT, but please remember your volume must be total and your pressure, mole, and temperature must be referred to that gases. Okay, so that's all for question 2.